Okay, guys, let's take a look at problem number 7 off of the 5-6 homework. And this is my first time trying to use Jamboard on my iPad, so we'll see how this goes. I apologize in advance for any clumsiness. So what's going on here? A cat falls from a tree. That's a fun premise right there. You know, the idea that a cat never, always lands on its feet and that kind of thing. Anyway, with an initial velocity of 0 at time t equals 0, and the question now is how far does the cat fall between t equals 0 0.5 and t equals 1 second. So they're telling us here to use Galileo's formula. I've heard of that guy before, and he's the one who came up with this idea that when an object is in free fall, its velocity can be given by negative 9.8 t in meters per second, assuming that t is measured in seconds. So the question of how far the cat falls is a question of distance. And we're going to go ahead and use the formula here for displacement. And our delta S formula was the definite integral from a to b of our velocity function v of t taken with respect to t. Now, I'll go ahead and tell you right now that if you were confused here as to whether to use the displacement formula or the total distance travel formula, which is really the same thing, but with an absolute value around the v of t, I don't want to say that it's not going to matter. I can tell you right now that because our velocity function right here is strictly negative, I know already that this displacement is going to end up being negative as well, which makes sense. As the cat is falling out of the tree, sorry kitty, its height is getting lower, which means its position is decreasing, and so its displacement should be negative. But the way the question was worded, how far does the cat fall? That's an important word right there. So the answer they're looking for is going to be positive. I'm going to go ahead and get that negative answer and then just realize that that's displacement. And to find out how far it actually fell, I'm just going to turn around and make it positive. So what's going on here, guys? Our displacement then is the definite integral of our velocity function, which is a negative 9.8 t. And we're integrating that with respect to t. And our limits of integration are the lowest and highest values of t, of time, in this little experiment. So we're starting here from 0.5 seconds, and we're ending it at 1 second. So let's see where that gets us, everybody. Anti-differentiating a linear function, we're going to keep the same base, t, raise the exponent by 1 to square it, and divide the old coefficient, negative 9.8, by that new exponent of 2. And this, everybody, is an expression you guys learned back in Chapter 3. That is the distance in meters that an object will fall in t seconds of free fall. So that's the antiderivative of negative 9.8 t. We'll put the evaluation bar at the end, and we'll take this thing from 0.5 up to 1. So I'm going to run out of luck here at some point because there's decimals involved and it's going to get messy, but I'm going to leave the negative 4.9 out in front, and then in brackets we'll go ahead and incorporate the b minus the a. So putting a 1 in for t squared is just going to get us a 1, and then minus, I don't know, that 0.5 squared, that's 1/2. Squaring a half is going to get you a quarter. All right, I'm not sure that I saved myself that much work here. So we're going to end up with a negative 4.9 multiplied now by a 1 minus 1/4. So that is going to be a 3/4, and the decimal times the fraction is going to get just a little bit ugly here. So, okay, that's about as much as I wanted to do by hand. Could I do that more by hand? I probably could, but never mind. Negative 4.9 times 3/4. So where am I here, guys? All right, same problem I was working on before. Negative 4.9 multiplied by 3/4 is going to get us negative 3.675 for this answer. Negative 3.675. Now, again, I feel comfortable with the fact that this answer is negative because obviously the cat's positioning is getting lower. Its height is decreasing. So it moved a negative amount, meaning that it got lower than where it started. But since they use the word fall here, how far does the cat fall? Giving a negative answer to that question, if you think about that, falling negative 3.675 meters kind of suggests that the cat's position is actually rising. So I think we're going to take that answer and just flip it around and make it positive 3.675 meters, and that is going to be our answer to this question. Now, if you really wanted to be thorough about this, probably right off the bat, we could have gone with the absolute value of our answer right here to get the distance that fell, but I think what we've got here explains our reasoning pretty well.